All right, so we're going to dive into this whole water thing. You know, we all drink it, we swim in it. It's pretty much everywhere.
It is.
You'd think we'd have it figured out by now, right? But I was reading this article from the University of Barcelona, and
Right.
they're saying that water is way weirder than we think.
Yeah,
Yeah?
it really is. Most people don't realize that water breaks like all the normal rules for liquids when you look at it on a molecular level.
Uh,
Like it's full of these strange things that scientists call anomalies.
Anomalies.
Yeah, and these anomalies are actually what makes water so essential for life as we know it.
Okay, so anomalies. So not just like, your average everyday quirks, right? So like
Yeah.
the article mentioned a couple that kind of blew my mind. Like water is surprisingly difficult to compress.
Yeah.
And like its ability to absorb heat, it's way higher than other liquids.
hmm
Can you explain a little bit about why these anomalies are such a big deal?
Absolutely. So these anomalies have been kind of a puzzle for scientists for a really long time. Like imagine trying to build a computer model that predicts how water will behave.
Right.
You'd think you could just apply like the standard rules of physics,
Yeah.
but water just doesn't really cooperate, especially when you get to like extreme temperatures and pressures.
Oh, wow.
It's like water almost has a mind of its own.
So how are these researchers in Barcelona like cracking the code? They mentioned something called the CVF model.
Right. So the CVF model
Oh.
is named after the scientists Coronas, Villanova,
Mhm.
and Franzese, and they use some pretty hardcore math
Okay.
called quantum calculations. And what's interesting here is that they're not just looking at individual water molecules. They're trying to figure out how like trillions of water molecules are interacting with each other,
Oh, wow.
like all at once.
Yeah.
It's like trying to understand the choreography of this super complicated dance.
That is wild. So what did they find out?
Well, their model suggests that there's actually a critical point where water can exist in two different liquid forms. Think of it like this. Under certain conditions, water can kind of flip between these two forms.
Okay.
And this like flipping point could be the key to explaining all of its really weird behavior.
Hold on. Two different liquid forms of water?
Yeah,
So the water in my glass could be switching between these forms right now?
potentially, yeah.
That's insane. But why should we care about this critical point?
Well, because it could like change everything from how we treat diseases to how we build new technologies.
Really?
Yeah, the CVF model shows that all these like weird things about water, its density, its energy, even something called entropy, are all tied to this critical point and how much it's like fluctuating. And that's not just theoretical. These fluctuations actually have real world implications.
Okay, I'm hooked. What kind of implications are we talking about?
Let's start with biomedicine. You know, how important water is for our bodies, right?
Of course.
Well, imagine these tiny fluctuations in water influencing how proteins fold and interact within our cells.
Proteins,
Yeah,
like the building blocks of our bodies.
exactly. And guess what? Scientists are exploring whether these fluctuations might be linked to neurodegenerative diseases like Alzheimer's, Parkinson's, and ALS.
Oh, wow.
If we could understand how these water fluctuations contribute to these diseases, it could lead to like completely new treatment approaches.
So we're talking about potentially like targeting the behavior of water to fight these diseases.
Yeah.
That's incredible. And the article also mentions some pretty futuristic applications too, right?
Right. We're talking about things like biotechnologies that could use water's quantum interactions to create artificial muscles.
Whoa.
Like imagine tiny machines powered by the same forces that make water so unique.
That's amazing.
Or water-based memristors that could revolutionize data storage.
Okay.
These devices could hold potentially like millions of times more information than current technology.
Wait, water-based memory, how does that even work?
So it gets pretty complicated, but essentially it uses water's density fluctuations to store information. And then there are things like graphene sponges that could use these fluctuations to purify water on a whole new level.
Okay, so from fighting diseases to building these futuristic gadgets, it sounds like understanding water on this deep level could really change the game.
It really could. But we have to acknowledge that the CVF model isn't perfect.
Mm-hmm.
It has limitations, especially at extreme conditions.
Oh, right. The article did mention that. Does that mean we're back to square one?
Not at all. It just means there's more to discover. In
Mhm.
fact, these limitations actually point towards the need for even more sophisticated models that incorporate what are called nuclear quantum effects.
Okay.
And who knows what we might find when we start like digging into those.
Yeah, that's incredible. It really does sound like a huge leap forward, even with the limitations. I have to admit, I'm kind of in awe of these scientists. Like they're unlocking the secrets of some hidden world, you know?
It is pretty remarkable.
Yeah,
And
yeah.
it makes you wonder, like, how many other things that seem simple in our world are actually governed by these complex quantum interactions
Hmm.
that we're just beginning to understand?
And what really gets me is that water is something that we experience every single day, right?
Yeah,
We drink it, we swim in it, we see it rain and evaporate.
exactly.
It's so familiar, and yet, like, at its core, it's this crazy dance of molecules and quantum forces.
Mm,
It makes you realize just how much we don't know.
exactly. And
Yeah.
think about it like this. For centuries, scientists have been studying water, trying to understand its unique properties.
Right.
It's only now, with the power of these advanced computational models, that we're really starting to kind of see the bigger picture.
Yeah, I feel like we've gone from the familiar feeling of water on our skin to this whole other realm of quantum mechanics and critical points.
Yeah.
And the craziest part is that this seemingly abstract science could have such tangible impacts on our lives.
They're really good.
So, as we wrap up our deep dive into the weirdness of water, I'm left with this sense of wonder and excitement.
Yeah.
Who knew something so commonplace could be so complex and hold so much potential?
Yeah. It's a humbling thought, isn't it? And it really makes you wonder what other secrets this seemingly simple substance might be hiding.
Right.
I mean, we've only just scratched the surface.
Yeah, that's what makes this deep dive so captivating. It's a reminder that even the most familiar things can hold these profound mysteries, and that, like, the pursuit of knowledge can lead us to truly unexpected and exciting places.
Definitely.
Yeah, it really makes you look at water in a totally different way, you know?
Right.
It's not just the stuff we drink anymore. It's like this secret code that unlocks all these possibilities.
Yeah, that's a great way to put it. And, the really cool thing is that we're still deciphering that code. Like,
Right.
each new discovery opens up even more questions, and it pushes us further down the rabbit hole.
Yeah.
It's a journey without a real end, which is what makes science so fascinating. Right?
So where do we go from here? What's like the next chapter in the story of water?
Well, the limitations of the CVF model give us some clues.
Yeah.
Remember how we said it didn't quite work at those extreme conditions?
Yeah.
Well, that suggests that we need to incorporate even more complex physics,
Okay.
like those nuclear quantum effects that we talked about.
Oh, yeah. Can you remind me what those are again?
Yeah, sounds pretty intense.
Think of it this way. We've been talking about how the electrons in water molecules interact.
Right.
Well, nuclear quantum effects take it a step further by considering how the tiny particles inside the nucleus of each atom
Right.
can actually influence water's behavior. So it's like zooming in on an already microscopic world
Right.
and finding a whole other level of complexity.
Wow. So it's like there's always more to discover no matter how deep you dive.
Exactly. And who knows what we might find when we start exploring these nuclear quantum effects, right? Maybe we'll discover entirely new phases of water or uncover even stranger anomalies than we can even imagine.
Right.
The possibilities are kind of endless.
So what you're saying is this is really just the beginning of the story.
Absolutely. And it's an exciting time to be following this research because with each new discovery, we're not just learning more about water.
Yeah. We're gaining a deeper understanding of the universe itself because in a way, understanding water is understanding the fundamental building blocks of life and matter.
Well, I can definitely say that I'll never look at a glass of water the same way again.
I don't think I will either.
It's amazing how something so simple can be so complex and mysterious. Thanks for taking us on this incredible deep dive.
It was my pleasure. And to our listeners out there, keep exploring, keep questioning, and never stop being curious about the world around you. Because even in the most ordinary things like a drop of water, you can find extraordinary secrets waiting to be discovered.